Hi guys, good morning. This is Vetri. Today we are going to see circular linked list and its implementation. Here we go. So first I just want to explain what is circular linked list. So circular linked list it's an linked list. The last node of the circular linked list points to the first node. That's the difference from normal linked list. Okay. See, here we can see the normal linked list, right? So usually it will be null. In a singly linked list it will be null, but as per the concept of circular linked list, so it should have the address of the first node. So what is the address of the first node? It is 100, right? So it will have the address of first node, see, and it points to the first node. That's it, right? And after making the connection, now it will become a cycle, right? So from the cycle, so we can define or we can refer any node as the first node, right? So here I can start from 7 also, I can start from 3, I can start from the first node which is 5. So that's the advantage of circular linked list. Okay, so let me draw the same linked list diagram by a cycle. Okay, $500, let's see. So from first node it will have the reference to the it will have the reference to the second node, and then it has the reference to the last node, and it has the reference to the first node. I forgot to write it. So that's a random address, right? Okay, so now it's become a cycle. So just a pictorial representation of the linked list. Okay, usually it's not, should not be like this. Okay, now I can choose any node as the first node from this list, right? Okay, let me explain with the coding. See here, as per the concept, so head will have the address of the first node. Initially we are going to deal the circular linked list using singly linked list. Okay, so it's going to be an implementation of singly circular linked list, right? Okay, now first I have to create data type for the node. So we all know that how to create it, right? Struct node, open bracket, into that. So what are the two fields we have? First one is for data and another one is for address of the next node, right? So it's going to be a node. The data structure for this next will be a node. See, I'm going to consider my data as integer, then struct node asterisk next. Then so what else I want? I can declare it head and the temporary pointer individually. Okay, now I have created the data type for this particular node. This is going to be the structure of a node. Okay, so it will have two fields, right? First one is data and next one is next. Okay, so data will have data, see, data and next. Okay, address, this one will have address of the next node. Now coming to the program, so what else I need? So here I have the pointers, different pointers like head and temper. So temporary pointer which is used to add the multiple entries to the linked list. Okay, so once we are doing the coding, you will understand the use of temp. Okay, so see, after the declaration, so I am going to introduce two more pointers, which is struct node head and temp. Okay, now I have introduced two more pointers. Now we can go to create by using void function, void create circular linked list CLL. Okay, and to the function, so first I have to declare. So under create, I am going to create a node, right? So data type will be struct node new, right? Then initially head value will be 0. So initially I don't have any data. This node currently I don't have any data. Okay, so initially head will be 0. Look, it will be null. See, initially I don't have any data into the list. After that, I hope it will be visible. Next, I have to create a memory location for this node, new node. Okay, so what is the function I have to use? I am going to use malloc for this pointer address. Okay, new is equal to, the typecast function is struct node malloc size of struct node. So we all knew that the structure, right? Okay, so now I have created, see, now I have created the memory space by using dynamic memory allocation method. Now, so I am going to ask from the user printf enter the data, so which is going to be inserted in the linked list. Okay, next scanf. So my data is integer, so I am using %d. Then where I have to store, inside to new, see, new data. So this is the data field and this is the address field. Okay, so new data. After that, so now I have filled the field data field, right? Next will be new next. Initially it will be 0 because I don't have any new node. See, just consider my data is 5 and I don't have any other node, then it will be empty, right? So such that I am going to introduce, see, when I am trying to insert a new node, my head will be 0, right? So initially when I am trying to insert, my head value will be null. So I can insert directly into the list because this is going to be the new node, right? So when I am trying to, now after, see here, after inserting a data, so here I have inserted a data, right? Now the head will points to the first node. Usually head will point to the first node, right? So that I am going to apply the condition if head is equal to 0, then there is no issue, which means the temporary pointer as well as head pointer will move to new. Okay, so temp and head will points to the new node, which is nothing but, see here, after inserting the head, it is going to be the address 100. Okay, so my data is 5. this one will head now. Okay, now when after inserting the first data, temp will point to the first node, which is new, and as well as head also points to the first node only if I don't have any data in the list. Okay, which means head is equal to 0. Okay, okay, so let me explain the else case. Here we go. See, here is the list. I have entered the first data as 5, address location is 100. Okay, the 100 200 is the random address. Okay, so it no need to be in incremental order, so it can be in any way, any manner. Okay, see here, so next data I am going to insert is 8. At currently, see, for that case, now head is not equal to 0, right? Head is point to here, as well as temp also points to here. Correct? For that case, so what I have to write? Else. So that's the continuation of the previous code under the if condition. Temp next is equal to new. See, this is going to be the new node, right? This is going to be the new node. See, temp next, currently temp next is here, this one. This points to new node. Okay, temp next is equal to new, and then temp pointer will assign to the new node. Okay, now temp next will points to the new node, which is the new node which inserted now, and temp pointer also will points to here. So it will switch over to the first node to the second node. Okay, so you can see the difference. Initially, whenever we inserting a data, the temp pointer will move to the new node. So that's the use of temp pointer, to insert a new data into the linked list, right? Okay, now we can close the statement. Now after that, so it's all coming under the case which is a singly linked list, right? So the coding is 99% similar to the singly linked list concept. Now the condition is, after inserting, here I have inserted one data, so I am going to insert one more under location 300, data is 7. Okay, it has the point, it will be 300 now, here it will be 200, right, the address. So 300 is the address, right? Okay, now as per the concept of the circular linked list, what is the concept? The last node of the list points to the first node. So actually, what is the first node? This is the one. Address which has 100, right? 100, which is nothing but it's a head, right? So it will have the address 100, which is nothing but, see, it's an address of the first node, right? So it will points to this. So how can we write the statement for that? See, temp next is equal to head. So this code, this line of statement is very, very important. So if we missed this, the usual code will be for singly linked list. Okay, so that would be any difference on it. Okay, so after that I can ask from the user, do you want to continue like that for inserting the more data, right? So we all knew that. How can we write? Printf, do you want to continue? So if 1 for yes and 0 for no. Okay, then scanf, I can colon choice. Actually I didn't create the variable choice. See, in here where I have to declare, in here I have to write integer choice in under create function. Okay, so after that, after making this, so where I should use this condition, so in this code after the head function, see here I have to use while choice. Okay, so then if it is 1, it will, the following code will run once again for inserting a new data. So if it will be 0, it will go to exit. Okay, so that's the use of this statement. Okay, so I hope you understood the logic for creating and inserting a node into the circular linked list. Okay, so let me explain how to display the data. See, okay, see, why display? So here I am going to print all the element, or I am going to display all the elements in the list. Okay, so in this list I have 3 data, right? So I am going to print right from the first. I can take any node as a first node, right? So first I am going to declare the variable. I am going to traverse the data by using temp pointer. Okay, so struct node temp. So we all know that temp will points to all the node one by one. So first I am going to make the condition initially if the head value is 0. So here I have the head value as 100, right? Initially head value is 0 means list will be empty. Okay, so there is nothing to print. So I am going to make the condition initially if head is equal to 0, print the list is empty. Okay, if not, the list is not empty, so it's very important, just keep listening. So first I have to make assign temp value as head. So what is head here? It points to the first node, right? So now temp will be here, it points to the first node, and I am going to apply one more condition by using while loop. Temp is not equal to, so usually what will be the condition in singly linked list? So sorry, here temp next. See, if I don't have any data next to it, so initially that what will be the next value? It will be 0, right? Right? But here what is the condition? If it is points to the head, that's going to be the last node, right? When I'm trying to display all the data in the list, if see when I'm considering this node, for example, after printing 5, it doesn't have any node means it will point to the same node, right? See, from the second node 7 and it points to the next node, so I can print this. And then in here when I'm trying to print 8, it points to the first node, right? 100, right? That means the process is going to end, right? So I'm making the condition temp next is not equal to head. See, while temp next is not equal to head, I can go printf %t temp data. right? So from temp data, which is nothing but, so these are the data. So after printing one by one, the temp pointer will move to all the element, then it will print everything. See, as per this condition, after that I have to increment it, right? Temp is equal to temp next. So after printing the first data, it will points to the next one. See, it will print by using this logic, it will print first two data, right? See, now here when I am trying to print 8, the condition will check while temp next is equal to head. Yes, so the process will come out from the loop, right? So it will not print 8 because the temp value, the temp next value is equal to head, right? So it will come out from the loop, so I can't print this data, right? So for that I have to write one separate code, separate print statement, printf %d, which is temp data, for printing the last node. So it's one of the method, okay, for displaying the data in the list. So I can print the first data initially, like initially I can print the head data, head value. After that I can make loop for printing all the data. So it's one of the method. So I hope you understand the logic of how to create the node and how to insert and how to display the content from the list by using this notation. So if you have any doubts, you can comment in comment section, or else you can write to wingslecture@gmail.com. So don't hesitate to ask the question. It will be useful for you for understanding clearly this logic, okay? So thanks for watching. Thank you.